Okay, continuing the mill jack. I did kind of see where this would come down and it would contact on the threads and wouldn't really come back any further. So one of the things that that we could do, since we located for that geometry, is when I highlight the slided screw and go back to the mates, there's a coincident, and if I right click and edit that feature, then the other mate would be to go to a distance, and we'll raise it up 1/8 of an inch. I'm going to go to the high side, rounding up. Notice that it went down, so I need to flip the dimension. I wouldn't want to reverse the mate alignment because that would turn the piece potentially upside down and conflict with some of the other mates. So that puts it at the top of the part, so we could still drive that piece down, but the anvil isn't going to come any lower than the knurled nut. Okay, and then the piece that I go ahead and hit OK. The piece that I forgot was that little pad, and so we need to look at a strategy to make it. Pad's going to line up and be clocked to the notch, so it's given as 3/8 by half an inch tall, 3/8 wide, and then no real depth called out specific. What do we have there? 0.2. So they gave the 30 degrees off the horizontal. Yeah, 0.2 looks like to the depth. So, and then they're gonna say match or to fit. All right, so open up the sketch. And typically that midpoint is going to be coincident. And then select the midpoint of the rectangle, it'll be vertical. Alright, and then we're going to be 0.5 by 200,000ths. Alright, so the problem that I see with doing that is not knowing what the used as the reference. The threads that are going to engage on that pad, we're not going to have a lot of engagement left on that side. So we still have to get the threads in, and I'm still kind of wondering how I'd make that. Is getting the threads to line up. I know there's going to be some up and down flow. It's not constrained that way. It's almost one of those would have to make a block and then EDM out the notch and have it pretty much fall out. So, oh, 1/8 inch, or sorry, the width was 0.38. The height was half an inch. Okay, so that makes sense. I'm going to extrude cut, and then go through all, and hit OK. Alright, so my cosmetic thread still lines up there. And we'll save. I'm going to wait for the knurl a little bit longer. Alright, let's see what we can do with the pad. And we'll set up that geometry on the minor diameter. Okay, so on the top plane then, open up the sketch. We ended up with, well, let's just do the math again, minus 1 divided by 18, so the 569, that's my base circle. We brought the 200,000ths out to from that point. So I'm just going to generate the same type of geometry. Select the midpoint, make it vertical to the origin. 3/8 and 2. Alright, so if we use that, I don't know if I can reproduce, well, know that, oh, we jumped out of it. Let's go ahead and extrude. And I'm just going to extrude that, that region. And we'll go ahead and, well, I don't really like leaving sketch 1 in there, so let me go ahead and get rid of that. Oh, and it was at 100 thousandths, so let's identify it and go 0.5 and rebuild. Okay. So if I go back and show that sketch, we're going to see if we can use that as the base circle of our helix. So to make a swept cut, now the question would be, can I do a cosmetic thread on this? But I do want to see if it'll make the swept cut. So in this case, I don't know that the threads would be an option. I don't know if the annotations are an option. So let's go ahead and go through this process, even though it's partial. All right. So to make a swept cut, we need a curve. We need the helix. All right, and then since it's not a unique or a dedicated circle, we need to convert that geometry in. Alright, now it has its own very own sketch. So sketch 2 will be the base of the helix and spiral for the curve. And we were doing 1 divided by 18 as the pitch, 0.055. And I don't really need to take it out that many. I'm just go to 0.56 as a rounding, because that'll help a little bit with the angle. And so 0, or with the threaded cuts. Number of revolutions, well, I don't really like that one. Let's go height and pitch. Alright, so we have the pitch at 0.56, the height for 1 revolution, but let's go 0.5, and then we'll overrun it by 60 thousandths. So that'll make sure that it clears. And then the start angle at 0 degrees, we'll be able to pick that up and go ahead and accept. Alright, so now the trick is to find 0 degrees. Alright, so it came back around and it's here, and that helps with it being internal to the geometry. So keep in mind that the wall, this has the curvature on it, and when we draw, let's see if I can do the right plane. Okay, so on the right plane, we're going to create a triangle, 60 degrees sharp. That one horizontal and for construction. Alright, and then our choices are to go to the top and pierce it to the curve, go to the middle and pierce it to the curve, go to the bottom and pierce it to the curve. One of those will work, and by overrunning it, it really won't matter. My preference is going to be to pick the middle. And then that's the endpoint, so we get a coincident. But coincident typically will say that that point can ride anywhere on this curve. If we pick the curve in the point, then we go into pierce. Alright, so got it in position, going to give it the 60 degrees. For the V, and then the height will be 0.055. I don't want it to overlap. And let's see, what did I tell? Oh yeah. So pretty much the next V is going to be just a little bit of a gap between this V because we're at the midpoints. So let's go back and select. And then of course with the truncated and threaded everything, we have just a little bit of a difference with the angle. Alright, so I just wanted to see what that value calculates that out as. So with the root radius and the crest and everything else, the threads get really interesting if we go to to fully create that geometry. Alright, so we have a sketch that is the profile, our sharp V thread. We have a helix that is the path. And if I select both of those, then they become the swept cut. Right, so it's going to remove the material going through the part. And even though there's nothing out here to cut, there is something. I'm not sure what that is. That's a little concerning. Let's go ahead and accept it and see what it does. Interesting. So it chopped something out of the bottom. And some little notches, so it would have been better off with the I haven't seen a swept cut do that. Alright, so we'll save that one for later. That's the technique. I will explore why exactly it did that. I'm going to suppress it. We're going to hide the helix. And as the complex, we can hide our base sketch. Alright, and let's just see if it'll put the cosmetic thread on a curved edge, 5/16 or 5/8 18. And it has the geometry, so it shows there. We go to the one, not really there, not really there. So that's kind of interesting. What that's going to do as far as the callout. So this was item 5, the pad. Alright, so at this point I think we could have just drawn that, and we'll put a note on the drawing, 5/8 18 thread, and then see what it does. Alright, so let's go over, I'm going to launch my File Explorer. There we go. And then we're going to go to the assignments. Alright, so when I close this, there is number 5, the pad. We still have that open, but I think we're through with it for now. And it's saying the assembly has changed. So I'm going to rotate around to where I can see that notch, and then we're going to take and drag the pad in. And that produces kind of the same insert as components as coming over to the SOLIDWORKS Explorer and picking those items out. Alright, so the annotations aren't being shown. So the other thing would be, I'd almost want to make this like 7/16 tall, because that gives it one thread higher or lower that it wouldn't be in bind if we went to the trouble of making this. And so that's coincident. And I can see the top. And so I don't know how much mismatch they were really counting on that piece, but I would think that I'd want just maybe even half a pitch that it could not have to worry about alignment. The other choice would just be to bring this to a higher class of fit, go to a 3B, and I think maybe the 3B tap and the 3B, or even as small as these parts are, cutting the threads and cutting it to a 3A and a 3B fit so that you have that resistance in the turn would be about as easy as making this little pad piece. So that is certainly an option that we would put on the table. Alright, so that takes care of the parts and the oversights. And in our process of building parts and assemblies, we're always doing that error checking. It's kind of a continuing process of what did I overlook, what did I potentially miss. We're ready to go on to the toolbox. So I'm going in the library. Toolbox isn't active. Toolbox only works in the assembly. So I'm going to go ahead and add in now, which is the same as coming up to the add-ins and telling it, which is the same as coming up to the options in the add-ins and telling it to load the toolbox. Alright, once I do that, then the design library is going to have all of these folders. And under ANSI inch, we're going to look for the washers first. And let's just go with plain type A. and we're looking for what would be an off-the-shelf. So selected narrow, selected wide. No, I'm just going to pick one. So the first one, kind of dragging to that area. No matching size for the component. It shows it as a 5/8, which is fine. So this one is a little bit bigger. So it did go to the 0.66, but it is really tight to that edge. So this would be a good time to fly the browser back in, and I'm going to go out to McMaster, and we're going to look for washers, standard. Doesn't really need to be anything special, so standard flat washer, general purpose. Probably would stay with the 18/8 stainless as a pretty much a generic all around. Right, and then 6/8, 1.5 inches. So that may have been the purpose of them making their own washer, is to reduce that size. So a standard 3/16, 1.25 inches, that would probably fit a little bit better. And then 50 to 60 thousandths for 55 to 70 thousandths on thickness. And then not rated on hardness. Alright, so that gives us a range. Let's Control Z. And then remove the washer. And then go ahead and save one more time while I'm thinking about it. So narrow flat. Let's see if that's going to be any closer. Nope. And then let's see, that's a wide flat. Nope, not helping. So the narrow is probably the better bet, and the piece is not going to quite fit with our design. Okay, so that being the case, we're not exactly finding what we want. Advantage to companies like McMaster and other suppliers is that if they provide you with a model, it's going to have their part number attached to it. It goes into your assembly. More than likely, you're going to order it from them. So, 70 cents a piece for the washer. I click on the part number. I go to its detail. We have the description. So that one did go up to 1.5 too. I thought I had the 1.25. Oops, wrong one. Needed to hit back. See what I was not paying attention to. 316. No, they were both 1.5. I must have jumped down. Alright, so that gives us a choice. Since the other washer was pretty close, now all the 5/8 are looking like they're well, there's a 1 3 or 5/16, but that's still an issue because we drew it at 1.282. Alright, so going back into the model, let's see if we can fit 1.5 inches in there, since our supplier, and most of the suppliers are going to have that standard size. So since I drew this in the base sketch, we'll come back and we'll see what kind of problem this generates. So 1.5, let's get that out of the way so I'm looking at it. There we go. So if we add the other 1/8, actually it needs a little bit of clearance, so let's see what it looks like at 1.53. And we'll see what that does to the fillet. Yeah, it's kind of what I suspected, is the fillet was going to have some issues. So if I edit the fillet from the assembly, I'm editing in context. I do want to be careful not to tie anything together that I don't want tied together. If it terminates at that point, then we'll see if that's okay. If the feature expert can resolve it into 2, or something about that cylinder intersecting, though, that's a little A little weird. Yeah, I guess that there is an overlap there then. Alright, so I'm going to go ahead and edit the part, opening the part. Oh, I put the fillet all the way around. Nice. Yeah, that was not a desired result. So I'm going to go ahead and just delete the fillet out of there. We need to look at that base sketch. Alright, so bumping it up to 1.56 gives it an overlap, and that's cutting into the face, or the 1.53. So if I go to 1.5, that could be a 0 thickness, which would be a problem. And we have enough room, and it depends on what we're changing here. If this is a new product, then I can make the change. If this is an existing product and we're reverse engineering or reproducing it for another production run, then I pretty much don't want to change that value, and I then have to decide if I'm going to make that washer at 1 1/4 to match up to the 1.28. Let's go ahead and see what it does. And then we'll hit close, and there's another fillet in there. So that one kind of comes around. Oh, it added fillets earlier in the mix. Alright, so I'm kind of okay with doing that. And then where is fillet 3? Or where was fillet 3? So I'm just going to edit the feature. Okay, so fillet 3 was along the edge. That was one that we didn't need. So that one just gets deleted. Alright, so this is a design review item that I'm going to want to mark by the appearance. So we're just going to do the face. And I may not be able to see it as well in the assembly, but we are a little deeper than the other part. Alright, so then what I was going to get at is if I could find the washer in the supplier, then clicking on that item. So we're all the way. It doesn't matter. Then the 18/8's fine. Clicking on that item, going to its detail, and then coming over, we can download the 3D SolidWorks, save that file, put it over into our working folder or into our design library, and be able to drag and drop it in just like we were doing the Toolbox items. Alright, so I can go ahead and close that. And I'm going to leave the fillets a little weird. We're going to go back to the preferred, put that in place. It is 5/8. Oh, and we do end up with a little bit of clearance, so what did I tell it to do? Alright, so its size is 1.31. Alright, so that actually helps. The narrow was pretty good, so let's go back to the original sketch. And I am editing, making these changes outside of the so 1 3/8. Problem here is still going to be that being undersized. Yeah, I don't think I want to do that. Oh, and then I put the wrong number in. Alright, so I don't want to do the narrow preferred because we're going to have to go look for it. It's not an easily obtainable item, so let's try again with the select. It's going to be for 5/8. And it wants to continue putting washers in. So that one's 1 3/8, that's a little bigger. Alright, and then that one was huge and that one was huge, so let's see, 1.75. Alright, so that being the case, let's go ahead and download. Alright, so save the 3D SolidWorks file. It puts it over into my downloads, my choices. Oh, hopefully it put it in my downloads. Did it finish? Okay, there it goes. Apparently I didn't get it clicked. Let's expand out for the assignments. I'm going to drag it directly into Assign8. If this was a common part that we were going to work with, then I would probably add it to the design library. Alright, so I'm going to drag this in. Well, I don't have a meat reference, so we're going to go concentric, and then rotate over. So just kind of left click and hold down, move it out of my way, and then we'll go coincident. I really don't care if it rotates or not, but I'm going to go ahead with that concentric and right click, and it's only the concentrics that you can right click and tell it to lock the rotation. Alright. So that looks pretty good, maybe not perfect, but I still want to bring that up in design review that hey, there's an issue here, or who's our supplier, what are they going to be able to get us. Alright, going over to the nuts, we're going to find it's going to be a hex nut because the machine screws aren't going to go that big. And then if we go with just a standard hex nut, drag it into place. This is a 5/8 811. Okay, so since it embedded itself, didn't quite finish. Alright, so I didn't get the mate references. We'll go ahead and concentric. And then same thing. And coincident. And then right now it's free to move. You can see it a little bit better with the hex, so we're just going to rotate it to a position. And all I'm really doing by going and finding the concentric mate and telling it to lock the rotation is that I'm losing the minus sign in front of it, so that I'm not thinking it's underdefined or if there's something else that needs to go in there. Alright, so the two set screws. Now we're going to go to bolts and screws, and this was a slotted screw. So what were we called out as? Get back over here. And so one was just a flat point, and the other one was the dog point. So let's see what we have to work with. Alright, so there is the dog point screw. It's going to go in too. And a little on the large side. Now it's a little on the small side. Scrolling down to the 1/4 Oh, I didn't set a length. So since I missed the length, I'm going to go back and edit the toolbox component. That's going to take me back into this mix. By 0.25. Well, that's showing it as 0.25. That wasn't much of a dog point. We have more than that to work with, so let's see what a 1/2 inch looks like. Alright, so that sets me up for concentric. We have the slotting here, so I'm going to go find that flat. Pick the in face, we'll make that coincident, and then we'll see how much it sticks out. Alright, so it's not even close to sticking out at this stage. So one more, edit the toolbox component, and let's go up to 3/4 inch. And now it's sticking out a little too far. Alright, so if this is just for alignment, it's not really stopping it. The screw moving up and down. Alright, so the nut and moving up and down on the screw really is going to position it. So this is more for alignment. So it's the screw's not turning the anvil and basically acting as anti-rotation. So I'm okay with that being a little sub-flush. Alright, and then the flat point should be the one that goes through. It is lined up with the pad. So let's see what we can find. Slotted set screw, cup point. So cup point is a little relief. Half dog, there we go, flat point. Drag it in. That one was a number 10. So 1032. And it will have, let's see what 7/16 looks like. Go ahead and accept and escape because I don't need to put any more of those in. Set the flat. Alright, so close it. Alright, so 4.4 was a little heavy on that one. Go back and edit the toolbox component. We'll go back to 315. So 5/16, that brings it out flush. Kind of like that. Doesn't need to be sub-flush. I would like to have the visibility. Alright, so we have that in place. I'm going to go ahead and save. That completes the assignment as far as our build. If you want to go on, the optional is to build out, and we're going to try and put in a screw mate with this. So I'm going to pull these guys into a new folder. So add to new folder is just off screen. And so these are my fasteners, or hardware, or whatever you want to call them. The pad, okay, since that's able to turn, that's going to stay stationary. What is going to move is that we need to find that sliding screw mate that said that we had a distance, and I want to suppress that. So if it'll let me right click and suppress, then when we pull on the anvil, that will kind of line it up. And actually, if we pull it the other way, that will kind of line it up. Alright, so I need one. And we're back into the assembly. We're going to go into the to the mate. And then let's see if I can move this without selecting it. So that gets me a little higher up. Kind of what I wanted. Alright, so that one is going to then switch over to the mechanical mates, and we're going to set for the screw. Revolutions per inch is a little bit easier, so we could do 18 revolutions per inch, or if we did distance per revolution, that would be our 055.5 or 56, whatever we lined it up to. And rotation is that when we are tightening it, let's see, where is that set? Reverse. I think we want it to be tightening it goes in. If we're turning this, it goes, well, we're going to see. Alright, so let's go ahead and hit OK. And then as I turn this, okay, as I push this down, we're going to see that turn. And then as we move it back and forth, and we're going to see it go in and out. The problem here is that it really can just keep driving through the part, and if I keep going, it will end up contacting somewhere. So I think this was a pretty good bet. We had 2 inches on the alignment, which we didn't use all of it. So really, we only have 1 inch of travel before it comes off of the piece, and then also 1 1/8 on the thread length. So yeah, it's gonna about do it. We want it to contact the bottom of the nut and then not be able to turn, and then from there you're lifting it out anyway. So what I'm doing is I'm setting up the math for the advanced mate that is going to be a limit distance. Alright, so from 1 inch, when I pick the 2 faces, high end is 1 inch, and that's pretty much going to take it practically off the part, but for our purposes that'll be fine. The minimum then will be 0.13. Right, and then as this, the check is going to be that I move this up and down, the nut turns. And the nut is able to turn, but it stops after it's made so many rotations and driven the part up. So if I'm screwing this in, then as far as visibility, so if we're turning the thread that way, it's bringing it in. Okay, I'm having a hard time visualizing that this morning, so I know if I was turning this, this would be going in, so we're turning opposite of the way that I would turn this to drive it in. I think that's correct. Okay, gonna have to ponder that a little bit. Alright, so if we want to make knurls, let's go ahead and save this, because if I crash the computer, then we're going to call it done. Alright, so knurls can be made with the swept, but usually I end up deforming them just a little bit, which is not as desirable. So I'm going to find the right plane. I'm going to open up the sketch, and I'm going to produce a center line from the center to the midpoint, and then we're going to put an angle on it, about 60 degrees. Right, so from midpoint to midpoint. Set our angle. So 30 on the included. Yeah, 60 would flatten out quite a bit, so 60 on the interior. Okay. So then we want to create a curve, and I did click on Save Document. No? Alright, so let's go ahead and hit Control S in case. Do not have the curve up there. We're on Features, and then this is going to be a projected curve. Do not want it to be a split line, so I need to get out of the sketch. And then that will open up to where I can do a projected curve. And it's going to be on faces. So we're going to get one direction. I don't know that it's going to let me share it. Let's see if it'll let me do a second curve with it. Probably not. Oh, maybe. Alright, and then if I bring it the other way, then when I come around, this will be facing the opposite way. Alright, so I don't know that I need both of those, but we're going to check it out. Alright, so for my direction then, from the center, let me have the line. Alright, so we'll wait for it. We'll bring it out, and then I'm going to pierce the curve. So selecting the endpoint, selecting the curve. I'll set that as a pierce. And then I want my diamond shape, which I'm just going to use the pretty much the same technique as the thread. So that'll go to the midpoint. Except let's stay with a 90 degree this time. Alright, so that's going to be perpendicular. And then I will make that over to construction geometry. And then let's see, for width, now that seems a little big, but let's see what 080 looks like. Okay, so that gives us our geometry. I'm going to make sure Sketch 9 is highlighted, hit Control C, and then we're going to do Control V. Duplicate it and copy it to the clipboard. Control C on the keyboard. And select the face. Control V on the face. There we go. Alright, so normal to sketch. Oh, I added sketch 10. I'll go normal 2. We're going to see what this, how this drives. I don't care particularly which side I go coincident to. We're going to go back to the center, bring it around, and get it pretty close. So the end point appears to the curve again, and then hopefully this will loft along that curve and make our geometry. So this is going to be a lofted cut. The two profiles are 9 and 10, and then the guide curve is the curve that we use for our geometry. It has the cut, and then it thinks it's doing bodies, so it left a little sliver there, which is not uncommon. And so since I see the solid bodies, or which bodies to keep, that's we could always go back with direct editing and remove it, but I'd rather just go ahead and complete out the sketch, and we'll bring that over and that back and just give it some additional distance. Point 1 is way plenty, and then this becomes the construction line. Alright, so that's going to get me out a little further, basically making sure that I have enough to overrun the entire cut. Make sure it's coming out. I don't really care about the perpendiculars. And we'll go to point 1 again. Yeah, did not quite get those parallels, so whatever it did for perpendicular, Control Z, and we'll just make sure that it's parallel to the line, and that will get away from the angle. Select, and then that goes for construction. Alright, so sketch 9 and 10 for the lofted cut, and then the guide curve is controlling. It is not necessarily just like the sketch. It's got a pretty good twist. Still trying to connect. Alright, so let's get rid of the guide curve at least initially. And it's going from point to point, so that would be that cut. It's the first time I've seen the handles do a better job than a guide curve. Okay, one more check of the guide curve. Pretty sure. No, it's trying to twist it around. So I'm twisting it a little bit. Interesting. Alright, so we'll clear the selections, we'll let it stay. Alright, so for the guide curve, we can either reproduce the geometry over on the second curve. I'm going to hide that, and we'll hide both curves. Alright, so the cut loft is going to mirror across the right plane. And we'll see what this ends up looking like. So the mirror and the cut then become part of a circular pattern, and the intent is to have these crisscross. And so it's going to pick up the face. And then 3, we're not really going to see anything. 30 is going to be a little more complex. And actually, Well, we're going to go ahead and accept it because I think if I get too many, my video card is going to freak out. Alright, so it didn't quite come to a complete diamond. If I kept adding, then we would get it. Let's see if I can find the number. Maybe we'll go up to, there's my instance count. So 36, and then to 42 would be increments. And not responding, that's a little scary. Alright, so let's just go up to 36 so it doesn't take forever to do this, and then we'll rebuild. And we're going to see that diamond shrink to a little more of a point. And so the neural knobs that I've 3D printed, this is the technique that I've used and had pretty good results with. Alright, so it's not to a sharp point, but we have just a little diamond on the end, and that looks pretty good. Alright, so again, this is optional. It does add, a little bit of flair when we go back into the part. It is kind of impressive to see that knurl, so if it's helpful, then go ahead and do it. Also with the threads, if we don't see it on anything else, we'll see it on the part, and so it has a little more visual appeal. Alright, so this is the point where I usually remember to start to put in materials. I'm going to fly this over a little bit so I can see. And so they have this as the anvil is a 1045. So we're going to edit the material. Yeah, 1020, so they do have a 1045. And then the phosphorus bronze on the pad. So basically a expand out, make sure we can see the properties. We'll edit the material. I'm pretty sure these, at least reasonably sure that they're not in phosphorus bronze, that they're not in the in my favorites. So put it that way. The neural was also a 1045. So if I was adding a lot of 1045, I would go ahead and include it. And we're seeing a little bit of change in colors as they go. The sliding screw then was also 1045. Alright, so in that case, let's manage the favorites. Let's see, not doing very much forever. Well, we'll leave it. SolidWorks materials, copper alloy, no, wasn't it? Was steel. We're going to go add to favorites, and then I can close. And now when I pick, I'll see it at the very bottom of the list. It'll get applied. The clamp bolt then was just regular 1020, and of course it wasn't in my list. So edit materials, 1020 steel, cold rolled, and then at last the base was just the clamp bolt base is just a plain carbon steel. Alright, so since it's a cast or a manufactured, then we'll have it in the mix. Alright, so save. Alright, for the drawing for this, build to save document. Interesting. I wonder which one. I'm sure. It might just be one of them, or it might have just blinked. Alright. So we go over into the to the drawing, and so I'm going to pick my A size. I have not created an exploded view. I'm saving that to the end. Also, I have not created any of the put in any of the metadata into the file properties for this to work from. All right. So my process, we're going to create multiple views. Don't know that I need all of those, but we're going to be able to take a look at them. Alright, so at this point I decide, I'm still having that video issue. I don't remember exactly how I resolved or if I resolved. So there it's seeing all the edges. There it comes back. I would like to see those edges in the models though. So we do use parent style. And use parent style, and then that brings it in. So it's just a matter of the radiuses and how much. And that went away again. Okay, close enough. I'm pretty sure there's a setting for that. I've got to go ahead and chase that down. Alright, so we don't need the anvil drawing. We don't need the neural nut. Also, we might suppress the neural nut if it stays complicated. I'm going to go back in, and now we're ready to do the exploded view. Alright, so I can come up to the command manager and go into exploded view, or we can come over to configurations. When I right click and say new exploded view on a configuration, then that will give me the steps. I'm going to go ahead and try to do the auto spacing. And so when we pick, we're going to have 1 and 2. And this could get a little ugly with all this geometry. Alright, so those are the 3 pieces that are moving with the auto spacing. And it comes out, and then I can move them back a little bit closer. And there's the set screw, and actually the pad didn't do anything even though it moved with. But I think that's fine. I don't know that I have to have that come all the way out to... And I don't think I wanted to accept that just yet. Alright, so we're going to go back in and edit the feature, highlighting the view. Let's go ahead and bring the set screw and the pad out. A little ways, and so just dragging on Z. Oh, it didn't really need to auto space those guys, so I'll go back and just uncheck that. Come out some distance. Alright, so watch out for the orbits, because anytime you see the arcs, it's going to allow it to rotate. Okay, so I'm done with that one. I do want to auto space the nut and the washer. Okay, give it a second to catch up. Apply. Done. Alright, so making sure that those are cleared. And then we'll auto space. Oh, I grabbed the nut somewhere. Oh, it took the nut with it on the other one. Nice. So explode step 1. Yeah, that wasn't the desired result. I think I'm going to go ahead and just delete that one, since I got out of sequence on it. Pick that in the washer. We're dragging up in Y. And then we'll go ahead and grab the clamp bolt, and it can come down in Y. Now there's no auto spacing on that one. No. Let's go back and double click, and I want to increase the spacing on that one and tell it that it's done. We'll go back into chain 4, and it really didn't need the auto spacing, so we'll go ahead and accept. Alright, so that gives me an exploded view. It's pretty visible. When I want to collapse, we're going to right click and collapse. That puts it back in. Now when I save it and go back into my drawing, I'm going to copy. So Control C, the isometric view, Control V. When I highlight, we're going to see the box now because there is an exploded state that it can select in the exploded state. Alright. So creating my additional sheets. I'm going to tile vertically. And we're going to go back to the... And so I can pull in for the base. And we're creating multiple views. And again, I don't know that I need all of those, but I'm going to go ahead and generate them. And then the clamp bolt. Pretty sure on the clamp bolt I just need the front and the... that would be the top. Okay, and that gives me enough description. The sliding screw, probably the same thing, the top and the front, unless I rotate. If I rotate, I'll add it in as a projected view later. And then the next sheet will be the knurled nut. And let's keep going with that, mainly because the side view isn't helping me with these, at least not much. We might do I'm going to say I might do an auxiliary view, but I don't know that that's very beneficial either. Okay, so bring in the pad. It's going to be like 10 times the size to be visible, but that gets all of the drawing information input, and now we can go back and decide bill of materials, callouts, dimensions. I brought in my center lines, so now I would switch over to dimensions, and then we could start going through and putting in a dimension from there to there. Also, since I did include a couple of, we want to go to the entire model on the model items and then marked for drawing, then there is my dimension, although I would have preferred it was up there. So let's see if we delete that and I go back and I pick the view and go to model items, entire model, import, no, just that one. And then if we're going to stay with our precision of the drawing is 2 decimal places and just the critical dimensions, we'll highlight and go to 3. Alright, so then things like diameters. And since I built those, I wanted to see if the hull callout would still pull. So if this had been a whole wizard item, I would have seen the spot face for the next depth. So diameter, I was calling out as a radius, and then the whole through. So maybe that becomes a section view. So at this point, it's ready to go through and dimension. I don't want to spend too much time on that. I'm sure there was something that I said I would do to these models. Why don't we go ahead and just drop in a bill of materials real quick. I can position these. This is going to get kind of busy. I don't know that I would include all 3 views in the isometric exploded view. So we're going to go just off of screen as tables. And under tables, then we're going to have bill of materials. When bill of materials pops up, we have quite a few options. We're just going to stay with the defaults for now. And then I'm going to place that one in position, see how big it is. Yeah, we're probably, as an extreme, let's go down to 1 to 5. Now it's not very visible on the views, but we'll auto balloon, and that doesn't look terrible. I would probably try to line up on one side, and that looks probably worse. So let's just stay with the circular or the square. Okay, and then since everything else was the 1/5, we do have a little room. I'm going to delete. So highlighting the column, right-clicking, and then I lost something there. So let's zoom up on it, and delete, and column, and that'll open up a little more room. All right, so 1/5 is a little small. Let's bring that one back up to 1/2 as the usable. Oh, that's neat. Referring to a view. Sort of. Not quite sure about that. We're going to stretch the magnet line, add the number 5 to it. Yeah, I don't know if that's a video anomaly or if it's actually trying to do that. 8 can come over here. And we'll pull those out. And we'll make a little more room for the set screw. Since 8's out of the way, we'll shorten that up. Alright, so the magnet lines just give me the ability to kind of work with these and keep them grouped together as I align them. Alright, so another couple passes, we'd have a detailed document for this item. I would go back to each of the parts then and add for the for geometry. Since I added it from the assembly, I'll say that should have written it back to the part. Let's double check. So material, plain carbon steel, and it may be that I haven't opened this up, properties, or there was the issue, I have not activated the custom properties. Right, so I do have to open each of these up, give it a part number. Once I apply, and then save, then I can rebuild and I'll at least see the information that's there. So we have another couple passes on these. We're going to call this one good and move on to 1341.